Have you ever burned your tongue on hot coffee? What's the ideal drinking temperature range and how long does it last? Here on Little Experiments, we're about to find out. To get an idea of the optimal temperature range, I first Googled it. Driftaway Coffee had a nice page about drinking in the ideal temperature range. They recommended a range between 140 and 120 degrees Fahrenheit. Coffee Fanatics also offered a guide. They recommended serving between 185 to 155 degrees Fahrenheit. Then I wanted to get more scientific, so I checked Google Scholar. It turns out I'm not alone in wanting to get scientific about enjoying coffee. PubMed had an article that observed that the preferred temperature range was between 155 to 125 degrees Fahrenheit, with an optimal temperature at around 136 degrees Fahrenheit, based on a survey with 300 participants. Another study looked at pain thresholds, although it describes the ranges in degrees Celsius, so we had to convert their findings back to degrees Fahrenheit to compare. Here we find that the optimal drinking temperature is 145.4 degrees Fahrenheit and ranges from about 162 to 130 degrees. Based on what we found, we'll take the ideal range from 155 to 130 degrees Fahrenheit. For our experiment, we'll use Starbucks' suggested mass to volume for brewing drip coffee, which is 10 grams of ground coffee per 180 milliliters of water, or in our case, about 39 grams for about 3 US cups of water. Standard drip coffee makers use a hot plate to keep the coffee in the carafe hot. If you pour coffee prior to the full brew, the initial temperature may be lower than if you wait for the entire brewing process to finish. Here we go. We'll set the timer and pour in our coffee. There is an initial steep transient increase in temperature as the thermometer senses the coffee, then a gradual decline as heat is lost. Here is a look at the raw data taken from our 4 trials of the experiment. We had different initial temperatures in each case and different lengths of time that we monitored the temperature for. We hypothesized that the temperature decline should be about the same for each trial, and if so, then the data will collapse on itself. To check this, we can align the data by using offsets on the initial times, which translates the data curve for a given trial left or right, resulting in the data plot shown here. We want to model this data with Newton's law of cooling, which is a type of lumped parameter model. Capital T represents temperature, little t represents time, capital T with a little a represents ambient or air temperature, capital T with parentheses 0 represents the initial temperature, and lastly, little r represents our parameter for heat transfer. We observe the air temperature and the initial temperature, but we don't know what little r is. So, we'll estimate it with our 4 trials and the data that we gathered using a least squares method. Here we have the ideal temperature range, which is 155 to 130 degrees Fahrenheit, the data, and our fitted equation. If we take the average crossing points for the data and the temperature ranges, we have the top crossing around 5 seconds and the bottom crossing around 21 seconds. Our equation uses r equals 0.02. We see that the equation slightly overpredicts the earlier temperatures and slightly underpredicts the later temperatures. However, it does seem to provide a pretty good estimate of the temperature decrease with time. Visualizing the time range on the x-axis, we see that our coffee is in the ideal temperature range for about 16 minutes. Alright, when it's 75 degrees out and your coffee is served at 165 degrees, we're going to have about 16 minutes in the ideal temperature range. But wait, what about coffee in the Arctic? How do we know how long we'll have then? We need to update our equation and substitute 10 for the capital T little a value since we're assuming it's 10 degrees outside when we are enjoying our coffee in this thought experiment. Our crossings occur at 3 and 12 minutes with the updated equation. What's your ideal temperature range when enjoying coffee or tea? How long does your drink's temperature stay in that range? Post your results in the comments, and thanks for watching.